Hello everyone and welcome to the No Name Academy. My name is Katie, also known as Insider PhD all over the internet. So these are going to be some short videos on the new OWASP API Security Top 10 that was just recently released. If you're already familiar with the OWASP API Top 10 from previous years, there's not too many changes. It will look really familiar to you, but there are some interesting additions and some mergers of some of the other vulnerabilities. These aren't really designed to be watched in particular order. You don't have to watch it from 1 to 10. And of course, if you're already familiar with a specific vulnerability, you can just skip that video. Without further ado, let's talk about API1, which is Broken Object Level Authorization. So Broken Object Level Authorization, or BOLAs for short, is a type of broken access control. Again, if you're already familiar with the previous versions, this is actually returning from the last API Top 10, and the real difference between the previous version and this version of the Top 10 is that access control is split into 3 different types at 3 different levels. So on this level, we're talking about the object, so the individual resource level. It's also probably one of the most common security flaws in APIs, so it's one of the ones where if you do nothing else, remember this one. So what exactly is a BOLA vulnerability? So fundamentally, a BOLA vulnerability is the ability to do some action to a resource that isn't yours. So APIs, whether they're GraphQL APIs or RESTful APIs, often are developed with this idea of CRUD. And CRUD defines everything you can do to a resource. You can create a resource, you can read a resource or read all the resources, update a resource, or delete a resource. Now, in a RESTful API, this will be one endpoint. As you can see on the example of the slides, read is get/API/resource name, in this case post/identifier, in this case 45. Or in a GraphQL API, it's going to look like one query for each of these, or one query to get and then a mutation to update or delete them. Now, any user should be able to create new posts on their account, but those posts should be linked to the user that's currently logged in. And with that new post, they should be able to read that post, to potentially update that post, and also to delete that post. It belongs to them, it's their resource. So in this example, we have the red user 32, which has the post of post ID 45, and the green user ID 5, and post ID 20. Now, the green user should be able to read, create, update, delete ones on post 20 because it's their post, and 32 should only be able to do those things on post 45 because that belongs to them. Now, we might have some interaction, so for example, even if it's a post that doesn't belong to you, posts are public, so you can read any post regardless if it belongs to you. But if you are able to update, edit, create or delete a post belonging to another user, or to, when with creation, creating a post on someone else's account, that is the vulnerability. It's doing something to another user's resource that they shouldn't be able to do, as determined by your access control model. And of course, access control models can be very different and can be things like framework specific. So it's this idea of being able to edit something that doesn't belong to you. So what can an attacker do with it? Like a lot of API risks, and certainly a theme you're going to see going through these videos, it depends on the API's business logic, what that API does. In particular, when we talk about multi-tenancy applications, where we have not just this idea of users, but of organizations, users belonging to an organization, and resources belonging to both a user and an organization, or one or the other, we can start to see how complex permission hierarchies can determine where this bug might be. But let's think about some practical examples. So an attacker could edit, read, update, or delete a resource they don't own. They could edit a post to claim a user said something when they didn't. In something like a cloud storage context, this might be deleting or viewing documents in somebody else's cloud storage. On a social media example, this might be about viewing private posts or photos. Again, it depends on what that API does, what kind of impact you could be looking at. It could be something really bad, or it could be something which, while not urgently or critically vulnerable, might be something you address in a later version. So why is this particularly a problem in APIs? APIs expose a really large attack surface. So for a RESTful API endpoint, for any individual resource will often have 5 endpoints. So the create, update, delete, and then we'll have read a single resource, so read post, and then we usually have another endpoint that shows us all of the resources, just read everything. And what this can mean is that your number of API endpoints gets out of control very quickly, particularly at the speed that new features might be developed. APIs will grow larger and larger. APIs often use easy to recognize IDs, though it's important to not rely on things like obscurity by looking at UUIDs, but it means it can be very easy to predict future IDs or new IDs. APIs may be developed, for example, in a mobile environment that assumes some client-side verification before being sent to the API. This might be the client adding a parameter in that specifies the user ID, for example. It depends. Because they can assume this client-side verification, often the API itself is left insecure. So if you want to resolve and mitigate these, some do's and don'ts, do design your API with access control in mind. You should have a very clear idea of what your access control looks like, what kind of access control mechanisms, and before an API endpoint is deployed and released, you should have a general idea of what kind of access control should be on each of that CRUD functionality. It's really important, in addition to this, to develop an AppSec program which supports developers and security engineers to produce or fix vulnerabilities, producing really nice, clean code. Each route should really be checked for access control, thinking about that wider access control model that might be in play. Some don'ts: don't rely on security by obscurity by using something like UUIDs. Identifiers can often be found in other API endpoints or potentially even in the read API endpoint, and simply having UUIDs often isn't enough to fully solve this vulnerability. Don't use tools that will automatically create API endpoints without first validating them that they do in fact have that access control model and that each route has been checked for access control. And finally, don't lose track of API endpoints. One of the really common ways this happens is that during development, more and more API endpoints are added, which is great, but can increase the attack surface such that there may be APIs out there that you don't even know exist. If you're worried about these types of attacks, No Name can help. Its Runtime Protection can detect and block API attacks with real-time traffic analysis, while its active testing allows you to test for API vulnerabilities in the development lifecycle before they're actually deployed. So that is the first video on API1 broken object level authorization. Thank you very much. I will see you in the next one.